In this video, I'm going to show you how to find the answer to a problem that we were looking at a couple of videos back. In that video, we were looking at a situation in which there was a population of incoming freshmen at a university. The population had a mean hours spent on a digital device per week of 40 and a population standard deviation of 20, and 100 people was being randomly selected from the population, and each of the 100 people was being asked, how many hours per week do you spend on a digital device? And the mean of the 100 people was being calculated by adding their 100 answers and dividing by 100. And we wanted to know the probability of the sample mean coming out to 38 or less in this situation. So let's talk about how to find the answer. First, we need to know if the sampling distribution is normal or close enough to normal, because if it is, then we can use the z-table to find the answer. So first, let's look at the shape of the population, because we know that if the population is normal, then the sampling distribution has to be normal. And the shape of the population isn't provided because all we can see right here is a box. So we can't use the shape of the population. We can't go by that. So let's look at the sample size. We can see that the sample size is 30 or more, and that tells us that the sampling distribution is close to normal no matter what the population looks like. So yes, the sampling distribution is close to normal. We know that now. The next thing we need to do is turn our sample mean of 38 into a z-score. And before we can do that, I need to explain the z-score of a sample mean, because this is a new type of z-score that we haven't seen before. Earlier this semester, we were talking about the z-score of an individual person. We learned that each person in a population has his or her own z-score. Now we're learning about the z-score of a sample mean, which is a z-score of a group of people, not just an individual. So the z-score of a sample mean is the number of standard errors that the sample mean is from the population mean. So back when we learned the z-score of an individual person, we learned that the z-score is the number of standard deviations that a person is from the mean. And the z-score of a sample mean is actually the number of standard errors that sample mean is from the population mean. So instead of talking about number of standard deviations, we're talking about number of standard errors. And remember that a standard error is really just a standard deviation. It's a standard deviation of the sampling distribution. So we really are still just talking about number of standard deviations. So let's try to find the standard error in this situation. The population standard deviation is 20. To get the standard error, we take the population standard deviation and divide it by the square root of the sample size of 100. We learned this formula in an earlier video. We learned that there's a long formula and a short formula, and we learned that the short formula is used if the sample is no more than 5% of the population. And in this situation, we're going to assume that the sample is not more than 5% of the population, because if this is a population of incoming freshmen at a university, then 100 people is probably less than 5% of that population, because this population is probably pretty big. This is probably a very small, or a pretty small percentage of this population. So we'll use the short formula. So 20 divided by 10 equals 2. That's our standard error. So now let's plot some z-scores on a diagram. The population mean has a z-score of 0, just like it always did before. And if we go down one standard error, the 38, if we go down by 2, we get a z-score of -1. So our standard error is 2, and we're going down by 2 to get to -1. And if we go down 2 again and we go down one more standard error, it's -2. If we start at 40 and go up, a standard error, it's plus 1. And if we go up another standard error, it's plus 2. Remember I said that the z-score is the number of standard errors. So our, our number that we're interested in, which is 38, has a z-score of -1. So if we want the probability of the sample mean coming out to 38 or less in this red area, we need to look up its z-score of -1 right here. So if we go to the z-table and we look up -1, we get 0.1587. So 0.1587 is the probability of the sample mean coming out somewhere in this area, 38 or less. Remember, the z-table gives you the probability to the left of the z-score. If we wanted the probability of the sample mean coming out above 38, we would do 1 minus this. So yeah, we got the answer we were looking for. It's 0.1587. And remember that this curve right here is the sampling distribution of all possible samples of 100 people. So just imagine a bunch of boxes under here, and each box being a combination of 100 people, and each box being placed above its sample mean. So right here, at this point, we have 100 people with a mean of 42. Up here, we have another 100 people with a mean of 42. And over here, we have 100 people with a mean of 44.